Hello, this is exercise 6, the axial skeleton. So the skeleton is divided into two parts. We've got the axial skeleton, which is what this exercise will deal with, and that includes the skull, the vertebral column, and the thoracic cage. The appendicular skeleton, which is the other part, that involves the pectoral girdle, the pelvic girdle, and the appendages. So the pectoral girdle is what attaches the arms to the rest of the body. The pelvic girdle, the hip, is what attaches the legs, and then the arms and legs. So today we're just going to focus on the axial skeleton. Once again, please don't forget to look in your lab manual under the review section, list all the bones that you are required to know for this course. So in this picture, you can see highlighted in blue the parts of the axial skeleton. As you can see, it's right along the torso, midline of the body. And if we start at the top with the skull, you have the cranium, or the bones that are surrounding the brain, and then in the front part you have what are known as the facial bones, and that's what gives you a lot of your facial features. Once again, I recommend that you find a picture from several different angles, several different positions, the front, the back, underneath, etc. That's not labeled. Make one copy of it and put it into a plastic sleeve, and then from there you can practice labeling it and then erase it, label it again, erase it again, etc. And just that repetition will help. To give you an idea of some of the bones, and like I said, the ones that you need to know are listed under the review in the lab manual. But here are some that you need to know in the very front. This is looking from, obviously, the front view of the bone. Right here, you've got the frontal bone, the parietal bone, and you'll notice that oftentimes for the bones, like you have the parietal bone here, and then also over here. So don't panic when you first see that, oh my gosh, there's X number of bones. Oftentimes on the right side, it's a mirror image of the left side, and so they'll have the same name, thankfully. One area that sometimes confuses people is, if we come over here, the sphenoid bone, right here. And you see it's over here, this yellow bone right there. If you look in the skull, it's often described as looking like a butterfly, but it's basically on the back side of the orbital, the opening where the eyeball is going to be. So it's going to be behind there. Then when you proceed on, often find a marking point or a starting point. The ethmoid bone, right, is listed right here. As you can see, it's the purple bone here. Now, as you move to the front, now the green bone that's right next to it is going to be the lacrimal. So on the very back, you've got the sphenoid. Then as you move forward along near the nose, you've got the ethmoid. Then you've got the lacrimal bone. And then right up front, where the nose is, you've got the nasal bone, which is right here. The cheekbone is the zygomatic bone. The upper jaw is known as the maxilla, and then the lower jaw is the mandible. Now, the lower jaw, has these very obvious holes on either side here. That is known as the mental foramen. Mental refers to the chin area. A foramen is a hole that allows blood vessels and nerves to move from one side of the bone to the other, in this case from the outside to the inside. So whenever you see that term foramen, think, oh, there's a hole there. The mandible, the lower jaw, is the only movable bone in the skull. All the other bones, you have joints, but they're fused together, so they're non-movable. You do need to be familiar with some of these joints. A suture, and I know this can be a little confusing, but a suture is one of these immovable joints that's typically found in the skull. The coronal suture is the one that is found basically between the parietal bone and the uh, frontal bone. So just in a drawing, it's going to look like a line. It's actually, though, a joint. The parietal bones, once again, you've got a left and a right. This is showing from the posterior, the back view. You've got the sagittal suture. That's another one of these immovable joints. You've got the lambdoid suture. You have got the occipital bone, which is along the back. Once again, start seeing how these the terminology that you learned in exercise 1, how it's coming back to play. The temporal bone, the foramen magnum. This is foramen, as we just mentioned, it's a hole. This is where you're kind of looking at a side angle of it. It's a hole here. It's where the spinal cord is going to come up and attach to the brain. Well, it has to be able to enter. And so the foramen magnum is a large, so it's a large hole in the base of the skull. The vertebral column is divided into different regions. You have the cervical region, which is, if you remember, the cervical area is the neck. So up here, it's going to be the cervical area. Thoracic, first off, we have 7 cervical vertebrae. Thoracic area is right here. There are 12 of those. Lumbar, think lower back. There's 5 of those. And then you have the sacrum and the coccyx. The coccyx is what's commonly referred to as the tailbone, and the sacrum is going to help form part of the pelvis. Those vertebrae are fused together. When we number them, we start at the top and work down. So as I said, the cervical vertebrae, there are 7 of those. So C1 would be the very top one. And then once again, for all the different regions, like the thoracic region, you're going to number them 1 through 12, so T1 through T12, etc. Now, on the side view of the vertebral column, you can notice that there are some curves here. We have what we call primary and secondary curves. So the thoracic curve right here is what we call a primary curve. It is there at birth. And then down here, the sacral or the sacrococcygeal curve right here is also another primary curve. Once again, it's there at birth. The cervical curve and the lumbar curve are secondary curves. These occur after birth or are finalized after birth. The cervical curvature, you know that is formed when a baby can now hold its head up. And then the lumbar curvature is set once an infant is able to sit up and stand up and walk around. The curvatures are helping to distribute the weight properly so that you can hold your head up, so you can support your body weight, stand up, walk around, etc. Now they continue to get they're formed, the secondary ones are formed early on, but they're going to continue and just kind of usually by young adulthood is completely formed. Now when you look at the vertebrae, if you look at an individual one, in the middle is, guess what, a hole. So that is known as a vertebral foramen. That is where the spinal cord is going to be running through. And so the bone is around it, protecting it. The body is going to be taking most of the weight, so it can transfer the weight from the upper body down. So that's why it's thicker. You do have these processes or these extensions that do set out. The spinous process right here, this back one, This is what you can often feel when you run your hand down your back and you feel, it feels like bumps. When you look at a side view of the vertebrae, and also straight down, you should be able to distinguish. Is that a thoracic vertebrae? Is it a lumbar one? Which one is it? How can you tell by looking at it? The spinal cord itself is largest or thickest at the top, and then it gets thinner as it moves down. So when you look at the vertebrae, look at the vertebral foramen, and it's typically larger in a cervical than, say, the thoracic. But because you're helping to distribute weight along the vertebral column as well, then the body is going to get larger as you move down. So the body area of the cervical vertebrae is the smallest. It gets a little bit larger with the thoracic, and it's largest with the lumbar. It's also going to be thicker with the lumbar. So if you look from the side view, look at the thickness of the body. The other big thing is look at the spinous process. Look at the angle. For the cervical and the lumbar, it tends to extend straight back, but the thoracic one is at an angle pointing down. So that's another clue that you can use to help. If you find just one vertebrae, distinguish, which one is this? And then when you look at the thoracic cage, this is going to have the vertebral column on the back, specifically looking at the thoracic vertebrae. Attached to this will be the ribs, and in the front you have the sternum. With the sternum on the front, it is divided into this upper portion is known as the manubrium. This jugular arch right here, you can actually feel that if you feel on the front. Your neck, you can feel that notch. Then you have the body of the sternum. That's the main portion right here. This is the area on which, if you have to do CPR, you will be doing your compressions on this. And then the xiphoid process is at the bottom. This is not fully fused together till later in life, and usually about your 20s. So it's very important to get the positioning right when you do CPR so that you are not doing your compressions on the xiphoid process. If you do, you have a very high chance of pushing that xiphoid process down into the liver, and now you have, obviously you have a huge problem, more serious issue right now if you're having to do CPR, but then you can complicate the problem if you puncture the liver. So obviously you don't want to do that. So at the sternum, you do have ribs attached to the front of this. The rib cage, thoracic cage, is surrounding your lungs and your heart, providing protection for that. With the ribs, they're numbered. There are 12 pairs of them. We start at the top, and as we number, move down. Ribs 1 through 7 are known as the true ribs because on the front, with the ribs, you have the bone, and then right here, this difference in color is showing that you do have cartilage that then attach directly to the sternum itself. And so 1 through 7 do attach directly to the sternum. So they're known as the true ribs. 8 through 12 are known as the false ribs because they do not attach directly to the sternum. 11 and 12, as you can see in this diagram, do not even touch the front. They're known also as the floating ribs because the front's not attached to anything. Now you may be looking and saying, why are 8, 9, and 10? They look like they're attached to the sternum. Yes and no. They are indirectly attached. So you have here 10, 9, and 8, and the cartilage comes up and it attaches to 7. So that's why it's known as the false ribs. So once again, review on the lab manual as to which bones you need to know. For this course, we are focusing mostly on the bone. Don't worry as much about some of the markings on the bone. I feel as though first, learn the bone. be able to tell me where that bone is. Can you identify it? It doesn't help to know all the markings on a particular bone if you can't tell me where the zygomatic bone is. So focus on learning the bones.